Hi there. Hope you have a fantastic day today. This lesson I will go through 2023 HSC paper with you. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Question 14, part I. Given a non-zero vector PQ, it is known that the vector Q negative P is perpendicular to PQ and has the same magnitude. Points A and B have position vectors. OA is A1, A2, and OB is B1, B2 respectively. Using the information given or otherwise, show that the area of triangle OAB is a half absolute value of A1, B2 minus A2, B1. And let me just construct the vector OA and OB first. Let's say we have vector A here. So A, A1, A2. And this is vector B. So that is B1, B2. And to find the area, so we know the area of a triangle. Okay, so we can work out by a half times base times height. So this means that this is the height here, height. And of course, this is O, and this is H, if you like. So we know that the area is a half of B, that is magnitude of OA, and times height. And we know that height is perpendicular to OA. And we know that we can construct a vector that perpendicular to OA and have the same magnitude. So we can construct a vector that is perpendicular to A. So this is A prime. So that is A2 and negative A1. And if we project vector OB onto vector OA prime, so it will give us the perpendicular height, because if we project OB on here, so that will give me something like that. It's the same magnitude with H. Okay, so this is vector here. Let me just write out here. So that is projections of OB onto OA prime. Okay, so this will give us the vector here. That is, have the same magnitude, okay, and parallel. So we just need to find that, and will give us the H. So we know that this H here is the magnitude of projections of OB onto OA prime. So this is it. So now let me just find the projections of OB onto OA prime. So the projections of OB onto vector OA prime, that will give me OB dot OA prime over the magnitude of OA prime square. And don't forget, we need the directions of OA prime. So there you go. But then H is the magnitude. Okay, so we just find the magnitude of these projections. So this is what we're after. So equal OB dot OA prime magnitude over OA prime magnitude square, and we times by OA prime magnitude. So this is the same, and what we do, we can cancel this out. So this here, cancel that. This will give me magnitude of OB dot OA prime magnitude over the magnitude of OA prime. There you go. So now area of a triangle OAB is equal to a half times base. So the base is vector OA. So that means the magnitude of this we just need to find the magnitude of OA prime. Okay, so let me just write this down. So that is times by the magnitude of OA, and we times by the height, so that is the projections of OB onto OA prime. So that means OB dot OA prime magnitude over OA prime magnitude. And don't forget, the magnitude of OA prime is the same as the magnitude of OA. Okay, so therefore, these two we can cancel out because magnitude of OA is equal to the magnitude of OA prime. Keep that in mind. And they cancel out. So that will give me a half of OB dot OA prime. So now that is equal to half. OB is B1, B2 dot OA prime is A2 negative A1. So A2 negative A1 and magnitude of this, of course. So now we just find the dot products. So that is a half. So B1 times A2. So that is same as A2 times B1. And B2 times negative A1 will give me minus A1 B2. So that is therefore area of the triangle OAB. So there you go. Part 2. Using part I, otherwise find the value of T that maximize the area of triangle OPQ. So in another word, we need to find the area of OPQ, this area here. So first of all, we need to find the vector OP and OQ first. Then we can find the area of triangle OPQ. And we know that OP, let me clear this vector here is OI plus IP. So equal OI plus IP. And OI is R0 because this vector here is R0. So R0. And we add IP. Now IP here is this. So we know that this is T. So this is the Y component. So opposite over hypotenuse. So if you think about it, so that means sine of T is it. This is Y component. Okay. So Y over the hypotenuse. And this is R, the radius of a circle. Okay. So over R. So Y is R sine T. And where is this X component? This component here, adjacent hypotenuse. Okay. So cos of T is equal to X over R. So X is R cos T. So this means that IP is R cos T, and this is the Y component, that is R sine T. So that will give me R plus R cos T, and then this is R sine T. So this is OP. Now we need to find vector OQ. And OQ is equal to OJ at JQ. So don't forget. So let me just write this down. So OQ is equal to OJ. We add JQ. And OJ is equal to negative R. Okay, R is just the radius of a circle. So the vector will be negative R0. And for JQ, so JQ is here. So this is R, of course, and this is, let me write Y here and X here. Okay, so this means that X is equal to R cos 2T in this case, and Y is R sine of 2T. Okay, same process as before. So therefore, JQ is equal to R cos of 2t and r sine of 2t. Okay, that is where we get these coordinate from. So now we just add them up. So this is exactly the same as r cos 2t minus r. And then this is r sine of 2t. So there you go. Now we have OP and we have OQ. So let me just rewrite it out for you here. Okay. So OP is r plus r cos t. And this is r sine t. Yep, that is OP. Then we do OQ. So OQ is r cos 2t minus r and r sine 2t. So that is OP and OQ. So let's just name this. This is like I1, I2, and this is B1, B2, right? And we know the area of a triangle. Okay, this triangle here, from part I, the first part, we have this. So half of the absolute value of I2B1 minus I1B2. So area is a half I1B2 minus I2B1. So now we just substitute these points in. So that will give me a half I1 is r plus r cos t. So I1 is r plus r cos t. And we times B2. So B2 is this one here. So that is r sine of 2t. And then we minus I2. This is I2. And this is B1. We just time them up. So that will give me r sine t brackets r cos 2t minus r. So now what I do, I just need to expand them out and simplify them, okay? So that will give me a half. So time together, give me r sine 2t and time it together plus r sine 2t cos t. And we time this together, become minus r cos 2t sine t, and then we plus r sine t, an absolute value. So now we just, let me just group them and I'll take out the common factor. So the common factor of this is capital R and lowercase r. So that will give me a half of capital R, small r. And let me just group them as well in here. So let me just write this first. Sine of 2t plus cos of t. And then we minus cos of 2t sine of t. So let me just write this out first. So that is sine of 2t cos t. And then we minus cos 2t sine t. And let me just write this down. Sine of 2t, sine of t left, okay? So we add sine of 2t, we add sine t. Absolute value, of course. Now what I do, I look at these two terms here. And this one here is one of the trig identity. Sine of a minus b is sine a cos b minus cos a sine b. So that means this is a and this is b. Don't forget one of the trig identity. So that will give me half r sine equal 2t minus t. So that means becomes sine t. And we just copy the other one down. So that means sine of 2t with plus sine t, an absolute value. And we can collect like terms. So these two we collect like terms. So that will give me a half R, and that is 2 sine t at sine 2t, absolute value. And of course, we need to find the maximum area. Okay, that's what we need to do. Maximum area of the triangle OPQ. Now, to find the maximum value, so please take note, we need to find the derivative of this, and then we make it equal 0, and we solve for t. Of course, we need to test it to make sure it gives us the maximum. So let me just name these functions ft, okay, to make it easier for us. So this means that area is equal to half r absolute value of f of t. So we know that f of t is 2 sine t plus sine of 2t. And to find the maximum of this, so we just differentiate first, and then we make it into 0, and then we solve for t, okay? And we test it, okay? So f dash t is equal to 2 cos t, we plus 2 cos of 2t. Then f dash t is 0, so this means that, let me just write this term first. So 2 cos 2t plus 2 cos t is 0. So we just need to solve for this. And we need to write this in terms of cos t. Okay, so we use double angle. So cos of 2t becomes cos square of t minus sine square of t. Okay, so that will give me cos square of t minus sine square of t is 1 minus cos square of t. So that will give me, I just write it here, so it becomes 2 cos square of t minus 1. So let me just write this down. So that will give me 2 brackets 2 cos square of t minus 1. We add 2 cos t is 0. So now I need to expand it and I factorize it. Okay, so I expand this first. So that gives me 4 cos square t minus 2 plus 2 cos t is equal to 0. So now I just divide everything by 2. So that gives me 2 cos square t, and write this first. So I divide by 2, give me 1. So that means plus cos t, and minus divide by 2, give me minus 1 equals 0. So I need to factorize this. So let me just quickly factorize this. That becomes 2 cos t plus 2 cos t minus is 0. And this should be 2, this should be 1. And I take the 2 out. That cancel. That give me 1. This cancel out. So that will give me cos t plus 1, 2 cos t minus 1 is 0. So this means that cos of t is negative 1, or cos t is a half. Now when cos t equal negative 1, so this means that either t is equal to negative pi or pi, because negative 1 is right on here, okay, on the x-axis. So negative pi or pi. But if you think about it, okay, in this triangle here, let me just clear this first. So when t is equal to pi, so that means it's right, p is on the x-axis somewhere there, okay, like there, because it's from here to here is pi. And then this angle here is 2 times t. So t is pi, so that means 2 pi. And they're all on the same line, so that means we cannot have t equal pi or negative pi. So this means that all p, q are collinear. So this means that all PQ can form a triangle. Keep that in mind. So cos t equal to half. So this means that is on this quadrant and that quadrant. So the reference angle is pi over 3. Pi over 3. So therefore, t is equal to negative pi over 3 or pi over 3. Don't forget the domain for t is from negative pi to pi. Now we need to test it whether at t equal negative pi over 3 or pi over 3 give us the maximum area of triangle OPQ. Okay, but then if you have a look at this function here, f of t is this. 2 sine t is an odd function. And then sine of 2t also an odd function. And therefore, if we absolute value, see we absolute value of f of t, so this means that this is even functions. Okay, keep that in mind. So if we absolute an odd functions, we give an even functions. So in another word, t is equal to negative pi over 3, t equal pi over 3, it gives us the same value. So we just need to test one of them to make sure it is a maximum. So let me just test it. So when t equal pi over 3. So let me just write this down. T, and this is pi over 3. And pi over 3, let me just put on a calculator. So just go shift pi divided by 3. So roughly about 1. So left of this will be 0.5 and right of the pi over 3 is 1.5, right? So 0.5 and this is 1.5. And we know that f dash t is equal to this function here. So 2 cos t, so that is 2 cos t plus 2 cos of 2t. So now what I do, I just put on a calculator. So let me just convert the calculator into radian mode first. Shift, setup, 4. So just go, so 2 cos 0.5, close bracket. We add 2 cos of 2 times 0.5 is 1. So there you go. 2.8 will do. 2.8. And when t is pi over 3, it becomes 0. Now, when t is 1.5, 2 cos 1.5, close bracket, plus 2 cos. Now, 1.5, 2 times 1.5 is 3, so cos of 3, close brackets. So negative 1.8. So negative 1.8. So that is the testing. So this means that we have a gradient positive, 0, and negative. So therefore, maximum, and we know that f of t, absolute value of f of t is even. So that is f of negative pi over 3 is equal to f of pi over 3. So therefore, the maximum OPQ is at t is equal to plus or minus pi over 3. So there you go, and thank you so much for watching. Bye.